Ta-da! Drum roll. Today we are going to actually look and find out why we have bothered so much about factoring polynomials. Because we are going to solve quadratic equations by factoring. This is the most elegant way that we can use to solve quadratic equations, and it is also the most useful and the easiest way to solve a quadratic equation. So, what is a quadratic equation? ax squared plus bx plus c is equal to 0. This is what we call the standard form. The a, b, and c, those are just any real numbers, like 3x squared plus 4x minus 3 is equal to 0. So when it is solved for 0, then it is in standard form. Now, the reason why factoring is so amazing is because we have what we call the zero product rule or zero product principle, which says that if I have two factors, sum a multiplied by sum b, and the result is 0, then it has to be so that either the first one is equal to 0 or the second one is equal to 0. If you're thinking about numbers, then this becomes very clear. For instance, 3 times a number that I'm thinking of, and the result is equal to 0. Well, what number can this possibly be? Well, it has to be 0, because otherwise you won't end up with 0 on the right side. And this works in the same way if the first number is some mystery number and I multiply it by, let's say, 5, and the result again is 0. This number in here, it has to be equal to 0, otherwise the product altogether cannot be 0. So let's go ahead and use this. Let's solve our first equation. Now the first equation is going to be fairly simple because it is already in its what we call the factored form. I have x plus 5 multiplied by 2x minus 1, and the product is supposed to be equal to 0. So, what are we going to do? Well, I'm going to take my first factor, x plus 5, and I set this one equal to 0. And I take my second factor, the 2x minus 1, and I set this as well equal to 0. And now what we are just going to do, we are going to solve these what we call linear equations. And that is always going to be something fairly simple. We know how to do this. So, here's the trick. Instead of solving a quadratic equation, I will split it up into two factors and solve two linear equations as well. So this is going to go fairly quick. In the first case, I just subtract 5 from both sides, and I get that x has to be negative 5. In my second equation, I first take the negative 1, I move it to the right side by adding 1, and now I'm dividing both sides by 2, and I get that x is equal to 1/2. So, and you see already now that I'm not writing those in-between steps down anymore. We are speeding up a little bit. So what does this mean now? It means that the solution set looks like this. I have two numbers in my solution set, the numbers negative 5 and 1/2. Let's do another one. We want to solve x squared plus 3x is equal to 4. This is not in standard form yet. So what do I have to do? I need to bring it in standard form, and that means it has to be equal to 0. This can be easily done. Let me write it down just one more time. Negative 5. I'm subtracting 5 from both sides. You really do not need to write this step down if you can just take the positive 5 and move it to the left by subtracting 4. All right. Now I have it in standard form, and now I need to have it in this way that I have something times something else is equal to 0. So I am factoring. Let's have a look. Two numbers that multiply together give you -4, but when you add them gives you +3, would be a -4, +4, and a -1. Checking, 4 times -1 is -4. 4 plus -1 will be +3. Works out. So, now what I'm going to do, I just simply set both factors equal to 0 and solve those linear equations. So, either x plus 4 is equal to 0, or x minus 1 is equal to 0. And you see that these ones are really very simple to solve. I subtract 4. Oops, let's eliminate that. I subtract 4 on the left equation, and on the right equation I'm adding 1. And that means now I have found two solutions. And my solution set, the numbers that are working, that would consist out of two numbers, the numbers -4 and +1. Now, what does this all mean? Why are we even bothering solving quadratic equations? Well, let's have a look at the graph of something. Here's the graph of y is equal to x squared plus 3x minus 4. Remember that we have solved this equation. Let me move this a little bit further down. We have just solved 0 is equal to x squared plus 3x minus 4. We have solved this equation. Now, the graph of y is equal to x squared plus 3x minus 4 looks like this blue line. Or if I would draw over it right now, I will make it orange. And we notice something. Another form of the same equation would be the factored form. This is what we used to solve this equation. And when I'm looking at the graph, I notice something. This graph, the graph of y, crosses the x-axis right here and right there. And where is that? That is at -4 and at +1. And we have just said that the solution set to this equation right here consists out of, well, there's an ugly parenthesis, consists out of the numbers -4, 1. So, in other words, the coordinates of these points are -4, 0. This is where y was equal to 0. And right here is the second point where y was also equal to 0. And the coordinate of this point is 1, 0. So the idea is this. Solving quadratic equations will enable us to find the x-intercepts of the corresponding graphs of the quadratic equation y is equal to. This will help us tremendously later on in the next class in college algebra. All right, let's do another one. We want to solve x squared is equal to 2x. And we will follow now the same exact procedure as before. First, this is not in standard form, so I'm going to bring it in standard form by subtracting 2x from both sides. Now I will have to factor, and I see that there is a greatest common factor of x in both terms, and I will get two factors, the factors x and x minus 2. And what I will now do, I have two factors. Here's the product of two things. I do not need to put a dot in between there. That means that this is a true statement. This is equal to 0 either if x is equal to 0, or if x minus 2 is equal to 0. Now, the first equation I do not need to even solve. The second one, all I have to do is add 2 to both sides. So I get that there is a solution, and the solution set consists out of the two numbers, the numbers 0 and 2. All right, let's do the same thing as before. Let's have a look at the graph of y is equal to x squared minus 2x. Now remember, just a second ago we solved this equation. 0 is equal to x squared minus 2x. And what do I notice when I'm looking at the graph, the picture, so to speak, of this y is equal to x squared minus 2x. Or another form would be to write it in the factored form. This is the exact same thing. This is the exact same graph. And I notice that the exact same thing happens as before. Down here, where this graph crosses the x-axis, those were the solutions to this equation right here. And this happens when y is equal to 0 for these 2 points, and these are called the x-intercepts. All right, let's go ahead and solve a little bit of a trickier one. So we are here to solve now this equation. X minus 1 times x plus 4 is equal to 14. Now, a lot of people tend to do this by doing the following now. X minus 1 is equal to 14, x plus 4 is equal to 14. But can I really do this? This is not okay. This I cannot do, because we said at the beginning the principle that we have here was called the 0 product rule, not the 14 product rule. There are many numbers that multiply together give you equal to 14. If I would say some number multiplied by another number that is equal to 14, well, that can be anything. The simplest one would be 1 and 14, or 2 and 7. But of course there are also many fractions whose product is 14. So I have to make sure that when I have to solve an equation like this, that I first need to bring it in standard form. The standard form is the most important part. So we are not going to do this. Now, there are two different ways how I can do this. I first multiply the left side out and then subtract 14, or I could first subtract 14 and then multiply out. I like to do first multiplication. So x minus 1 times x plus 4, remember, we are foiling this whole thing out. First outer, inner, last. X times x is x squared. X times 4 is 4x. Negative 1 times x is a negative 1x. Negative 1 times 4, that's a negative 4. All right, I combine like terms. I have a 4x and a negative 1x. These combine. These will be a positive 3x. Now I'm going to subtract 14. Maybe I should write this down. Maybe I should. Because this 14 on the left side does not disappear. Negative 14 minus 14. Now that will be a negative 28. Uh-oh. This looks complicated. Now, if we did this right, then we are going to find two numbers whose product is negative 28, whose sum, on the other hand, is positive 3. So, can we do this? Can we find two numbers? I believe we can. 4 and 7 look pretty promising. Positive 7, negative 4. Which one you write first doesn't really matter. X plus 7 times x minus 4. 7 times negative 4 is negative 28. 7x minus 4x is 3x, and x times x is x squared. This works. So the rest is a piece of cake, but we should still write down these steps, because now I have the product of two things who is equal to 0. And that means all I have to do is set both of these factors equal to 0 and then solve the corresponding linear equations. Subtract 7, add 4. So we have a solution set, and the solution set consists out of the numbers negative 7 and positive 4. I usually write the numbers in such a way that the smaller one comes first. Now here's the thing, I have not prepared the graph for this, but would it surprise you if I would tell you that y is equal to x squared plus 3x minus 28, that the graph should roughly look like the following? Let's see, where should it cross the x-axis? In other words, where are the x-intercepts? Well, here we have them. Let's just say this one right here is positive 4, and that right here is negative 7. Then I'm going to tell you right now that this graph right here would roughly look like this. Not a very pretty graph, but it's okay. We know where the x-intercepts were, because they were the solutions to this equation right here.